The ratio of the angle measures in a triangle is 1 to 6 to 13. What is the measure of each angle? So we have 3 angles on a triangle, and from last year or from middle school, hopefully you remember that whenever you add 3 angles, so let's call this one angle 1, angle 2, and angle 3, when you add these 3, you should be getting 180 degrees. And here's a little throwback to your geometry symbols. So this means angle. So angle 1 plus angle 2 plus angle 3 should give you 180 degrees. So now they give us the recipe here, which is 1, 6, 13. So we have 1 to 6 to 13. So when we add these 3 together, we're supposed to be getting 180 degrees. So here we have 1 plus 6 plus 13. Remember, these are all degrees. But here we do not get 180 degrees. The problem here is that this ratio is in reduced form. For example, if we take a look at our protein shake recipe, it's like if we didn't know this part. Let's say you went on Google and found this recipe, and this is the original one you found. But when you started reading, you notice that this recipe was for 2 servings. So in order to make it for 1 serving, you had to reduce this for 1 person. So here, that's what we're doing. We're trying to scale this recipe. So in order to find the actual measures of each angle, we're going to have to multiply this part by a scaling factor. So here, I'm going to get this left-hand side, and I'm going to multiply it by a scaling factor x. So now using my distributive property, x is going to multiply to each element inside of my parentheses. So x times 1, that's 1x. 6 times x is 6x, and then 13 times x is 13x. And now we have to solve for x. And now here, let's distinguish the left-hand side from the right-hand side. Here we can see that they're all common terms. So 1 plus 6 is 7, and then 7 plus 13, that gives us a total of 20 x's. And this is equal to 180. We want to isolate x, so we have to eliminate the 20 by doing the inverse operation. And here, this is 20 times x. The inverse of multiplication is division, so we're going to divide by 20. But whatever we do on the left-hand side, we're going to have to do it on the right-hand side. So the 180 gets divided by 20 as well. 20 divided by 20 is going to give us a total of 1. So we get 1x equal to 180 divided by 20. That's going to give us 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1 times x, that's just x. And we get x is equal to 9. So here, 9 is our scaling factor. So to get the measurements of each angle, which is what the question originally asked, we're going to multiply this reduced ratio by 9. So 1 times 9, that's 9. 6 times 9, that's 54. And then 9 times 13, well, I know 9 times 12 is 108, so 108 plus 9, 789 is 117. So these are the measurements of the angles of this triangle, and that would be our answer. And when you add these 3 up, you should be getting that 180. So let me just go back to that protein recipe. Here the scaling factor was 2, right? We multiplied each one of these times 2 to get this recipe for 2 servings. Let's try one more of these. So example 4. Now the ratio of the width of a rectangle is 1 to 2. The perimeter of the rectangle is 36 units. What is the measure of the lengths and the width of the rectangle? Now here, this, to make more sense here, I'm actually going to rotate this rectangle. Okay, so the length again is the width of a rectangle is 1 to 2. Now it can be argued which side is the length and which side is the width for a rectangle, or because here we can rotate it. But technically the length is referred to as your height. So your length is this part right here, and then your width would be that part right there. And for a rectangle, here, this quadrilateral is nice because this side is congruent to this other side. So here L is going to be the length of the other side. And the same thing here, the width, these two sides of the rectangle are also congruent. So here we have W. Here, the reason I rotated this triangle is so that this problem would make sense because the width is actually smaller than the length. So here we know that the perimeter is 36 units. So perimeter is basically adding the lengths, all the lengths together alongside the widths. So it's this outline. So if we wanted to calculate the distance of everything I just outlined, I would add these values. So here, to get the perimeter of 36, I would have to do L plus W plus L plus W, and that would give us 36. Now let's plug in everything we know. So we know that the width is 1 and the length is 2. So here, let me do this in green. So here we can say W is 1, and then let's say L is 2. So technically, if we make the substitutions, we should get 2 plus 1 plus 2 plus 1, and that should give us 36. You can see that this is not true, so that means that they gave us a reduced version of the comparisons. So we're going to have to multiply this by a scaling factor. So let's actually add all of this together first, and this is not equal for now. So 2 plus 1 is 3, 3 plus 2 is 5, and then 5 plus 1 is 6, so we have 6. And then we want to solve this quantity multiplied by a scaling factor. So that's what we want to solve. So 6 times x is 6x. And if we isolate x here, we divide both sides by 6. 6 divided by 6 is 1, so we have 1 times x. 36 divided by 6 is 6. And now 1 times x is just x. And we get x equal to 6. So 6 is going to be our scaling factor. And to find the sides here, let me do this. I'm going to have to multiply this by 6 and then this by 6. So 1 times 6 is 6, and then 2 times 6 is 12. So what is the measure of the length and the width? Well, the length is 6 and the width is 12. Sorry, I always spell length wrong, but this time I got it. Yeah. So 6 to 12. So now we got the correct comparison here. And you can double check this as well. 6 plus 6 is 12, and then 12 plus 12 is 24. 24 plus 12 gives us this 36. So try out the next couple of examples, and then when we come back, we'll wrap this up with proportions.